on the role of advanced composites in mass transport, now we have a panel discussion. For that, I request you all to join your hands and let me call Mr. Sameer Agrawal, CSO, Arvind Composites. Sir, on behalf of all the audience, I request you to be the moderator for the session. And the panelist would be Dr. Ankush from ATIRA. He'll be presenting the researchers side. Then we have Professor Mamta Saiyad from Nirma University. Professor Sham Gurav from Ahmedabad University. And to represent the private limited company side, we have with us distinguished Mr. Mukesh Sangvi, Managing Director, Indore Composites. May I request all of you to please join on the stage? So, sir, humble request to keep it. No, it's not required.
It's not required. Okay.
Yeah. So, sir, requested 35-40 minutes. Or I'll give you Oh, yeah. Is Mr. Mukesh Sangvi here? He was there before the tea session. Okay, he's on call. Okay, sir. All right. Please, sir, the stage is all yours.
Yes, we can sit here closer, maybe. Sure. All right. Good afternoon. It's wonderful to be here in the lovely campus of Ahmedabad University. It's always a pleasure and privilege. I'm very thankful to Dr. Ratan Singh for giving the opportunity to be able to ask a few questions from a set of very distinguished panelists I have. As I was reading the invite, I noticed that I was supposed to speak to 5 PhDs in composites, and I was like, wow, it's like a setup. So, you know, this conference combines participants from both academia and research side, as well as industry. I come from a more commercial industry background, represent Arvind Limited. We have a $50 million business which is into manufacturing of composite products, which is the reason why I know a little bit of this tech from a commercial angle. We do have different products and processes which need parts for not just mass transportation, but for many, many applications. For today's discussion, obviously the topic at hand is how composites can be, you know, what role composites play and how they can help advance the mass transportation industry. And again, for the purpose of this conversation, we can agree for mass transportation to include railway systems and buses. Because to take broader transportation, the aviation will be some set, but let's not keep that out. What I'd like to do is to really, give your thoughts on 4 or 5 themes, and other than making a specific one-on-one conversation, I've just lay out those themes that are only useful. And of course, this is from a commercial lens, like I said. One is really from an application lens, right? We all, pretty much whoever has anything with composites knows that today in modern trains and buses, composites does get used for a lot of, exterior interior parts like panels and ducts and so on and so forth. It will be interesting to hear from you if you have seen more interesting use cases of composites in the context of mass transportation, because that's the opportunity set. So that's kind of one area that we can discuss. And why composites in general is a better material of choice for many of the applications in the empty space. So that's one. The second is I'd like to get some insights from you around the materials and processes, because composites is a very wide subject, and what specific kind of combinations are useful for making these parts which we discussed. And what are the kind of, limitations? Because as I was kind of, going through the different applications, what I realized is that, for instance, one is this whole FR property is very important. Just being it systems and products. And in the process of making something fire retardant to that level, you end up loading either fillers or coating, and it ends up adding weight. So that's just an example, but in general, what are the limitations of using composites in mass transportation? There's a third thing. Fourth thing is, around sustainability. And again, it's a broader topic, not just for MD application, but this gets asked many, many times. So, with your permission, I'd like to ask, what's the thinking and progress on being able to treat composites at end of life? So that's one part of it. And even as you kind of make, there are a lot of conversations around environmentally sustainable resins, how practical it is, right? And then we wrap up with what implications all of this has for the industry and academia. What would be your suggestion and imperative? So broadly, that's the way I thought we'll structure our next half an hour or so. So with that, let me kick this off in terms of getting you started, ma'am, on what do you see are the interesting applications in the MT sector for composites, some of it which has been already established, and the ones which are more emerging and new.
Good morning, everyone. I suppose I am audible up to 10.
Yeah, you are a little.
Yes, I will try because I have that habit because my students are always picking up the last benches. So yes, thanks for the question. Very interesting to discuss about mass transportation because it is according to me. I will come back to your question after giving some prior this that composite, as we all know, is a very wonderful material. Strength to weight ratio, then the manufacturability and material selection, material availability. All these things are very wonderful for composite because we can make a tailor-made material and we can use it. So the advantages are lots of. At the same time, we have some challenges and we also have some disadvantages and we also have some responsibility with composite. So according to me, if we go for the some applications, there are lots of applications, locomotives and our bus. There are even a large part and a small parts. Challenges are with both large and small. So we also have to cater the need of both the parts, if it is a large part or a small part. I am not specifying any part over here, but the thing is that there are two main challenges. I will come up to the main challenges we are facing composite. One is the safety aspects, and second is the recycle, or and third I would also say the scalability. Because many times what happens that safety, according to me, safety comes first in the mass transportation because there are fire safety is we have to take care because this material is highly combustible and the flammability is high, and at the same time is leaking also. So in mass transportation we have to take the safety aspects first, and second is the recycle because as it is a mass transport, we are using the material also in mass, and after a period of time, it has to be recycled, and that is why the lots of research is needed to be done. And for the third challenge is in the research that whenever we are going for the research, this material is somewhat we all know that it is few decades older. I may say that it is very young material. So we get very less prior art or very less historical data, and because of that, doing the research, there are certain challenges. Another thing is for researching, we need some infrastructure, and that is also kind of a challenge. But altogether, if we do this and if we come up with the solutions, then definitely this material can do better in mass transportation. But still, there is a lot to go for doing all these things. So that is what my views on this mass transportation, composites in mass transportation.
Thank you. Koji, why don't you go next?
Like as rightly ma'am said, that there is a role of the advanced composite in the mass transport very much. So, like about the transport sector, that is a transportation of the transportation from the like the conventional material to the advanced composite material, where the role of advanced composite material is not only the material choice, but apart from that, it is a strategic asset where we how do we see that how we can design, we can build the material for all operative or the vehicle operative, including roadways, railways, aerospace, maritime, and India, this particularly composite industry, they are doing well now. If you say that the last 3 to 4 years, 5 years, that were having also mass transportation, the Vande Bharat that already is there, being made in India. So where like now we are just come up with a certain, these are the opportunities that we can say that where Indian composite is targeting. Apart from the opportunity, there are still challenges that like from these 2 days already we are talking about the cost and the availability of the raw material, which is very much important. These are the 2 crucial challenges that we need to be cover up. We come up with a proper solution for that. So like already the Petra is now making the carbon fiber, which can be the maybe in the future after 5 or couple of years that can be one of the major user of this particularly carbon fiber in the mass transportation. These are the things that we have to work out on that. So with that, I can say that yeah, these are in the advanced composite. There are opportunities. Parallelly, there are challenges that we need to come up with that.
Of course. So, Sham, you can share general remarks also, but specifically you want to build upon the aspect of safety, which in my mind is a very crucial element in the mass transport application, because you're talking of something which is a day-to-day for a large number of people. You could just kind of share your thoughts on that.
Yeah, I mean, I will come to that. I'll just try to bring another question, like for rail transport and all these. So I'm trying to bring a little bit aerospace applications where the composite is, and let's say 20 years back it was used to some extent. If we see today, they're claiming full aircraft is now composite. Now, what is happening in these 20 years? So every component of the aircraft is now composite. So every critical landing gear or anything inside the wing or something is replaced with composite. That's not happening if we come to, let's say, automotive sector. We're still sticking up with more of a superstructure kind of thing. And what I see is, as Adam pointed, this material is a little bit new. We don't understand it fully. So what we are trying to do is take the metal processes, like you start with all the design processes for metals, and try to replicate it when it comes to composite. So providing the holes and how you clamp and all those small processes, we're simply borrowing from the metal. Metal is very mature with the data, experimental data and everything. Composite is very not there yet. And that is, I think, stopping us from using this material at a critical component. Aircraft industry, they spend enormous resources to study this material's use for a critical. Their data doesn't get published outside; it's not available. So what I see is most of the automotive industry, for example, in the previous talk, metal matrix composite, it's a beautiful material, but it's not yet used enough. Um, so these industries, they have their own data. It's not yet for everybody, or there is no standard, especially when it comes to composite. And I think that is stopping us to go for a critical thing. And I think when we start using composite everywhere, right, in shafts and everywhere, where we actually get much of the weight reduction, and I think that's what I see stopping. Coming to safety, yes, I mean, we have to for composite with coating and what kind of ingredient we use in the say still need.
Very interesting, very interesting. So what I'm hearing is that there is a set of technologies and solutions which exist in the aerospace domain in terms of applications. And if only some of those were to be able to trickle down and flow into automotive and transportation, there could be a much bigger adoption of composites. Is that the main point? So, I mean, from the commercial side, so I have to ask you, you guys have been in empty space for a long time as well. So from a commercial point of view, where do you see the use of composites in the mass transportation sector, broadly speaking?
So, let me just touch base on 2 points here. First thing is, as you rightly indicated, the commercial part. So, when we talk about the penetration of composites in any of the mass transport applications, what showstopper there are 2 showstoppers basically today. First thing is the commercial, because it always boils down to piece of kg per your composite application, which is going on to your public transport in the form of railways or metros or buses. And that's where the challenging part is, wherein cutting down the cost by even 50 paisa per kg or even 1 rupee per kg is going to be valuable. So that is what we are looking at when we discuss the entire domain of mass transport. And the second part I would like to touch base is the sustainability part. I think in your initial introduction you mentioned the sustainability part also. So somebody yesterday mentioned very pertinently that what would be the best F1 car design. The guy said that once the car crosses the final line, it should get dismantled and go back on the shelf to get reused. So that is what sustainability is going to be. So currently we are looking at India standing at 0.4 kg per capita of composites. US stands at 14 kgs. But looking at the quantum of population we have versus what they have, even 2% penetration would equivalently match the amount of composite getting used in India. So we see the cause of concern in this whole application domain is the end of life cycle concerns. Because even if that 2% penetration of composite happens in India, kgs I would say, you would be equivalently seeing composites everywhere around. What today we don't see. So end of life cycle is what is going to be the sustainability is going to be the challenge moving here on. So yesterday we had a discussion on microwave technologies causing the disintegration of the finished goods, splitting them into composite resins and glass fabric and all that. So more of such technologies would be required to be brought into each and every domain. We're seeing windmill sector getting these technologies from Arvind, I would say Aditya Birla. They have a system to dissolve the epoxy in the glass fiber and separate it. Such should be the penetration in each and every segment of composite, because the end of life cycle is going to be the concern. You implement composites today, but what after 10-15 years when the thing gets disintegrated? You have a heap of composites sitting around you, and then you start thinking what to do about it, as it happened in the US for the windmill sector. So that's going to be one showstopper or maybe a roadblock which people will cater as far as absorption or usage of more and more composites in automotive and mass transport is concerned. So commercial is one, of course, because our L1 philosophy somewhere hits us at every point in time. So every organization, may it be a metro in a tier 1 city or a tier 2 city, every design is different, every safety standard is different. They have somewhere we have phenolic reflex, we have polyester resins. But you have the standards. You have EN 45545, HL1, HL2, HL3 taking care of your safety standards. So on safety you are covered. On design you are largely covered because there are experts in Storm, Bombardier, Titagarh, which these guys have evolved designs over the period. So these two facets from my angle are pretty much well covered. What is not covered is the commercial part. Second is the sustainability part. That's what I would like to sum it up.
Right, thank you. That's a very succinct kind of description of where we are in terms of challenges. One other topic which comes to mind is this whole repairability. Right? That's always a question mark. So, any of you would like to kind of weigh in on how far we have come in terms of being able to repair structures or components or parts that are made of different kinds of composites? Because it's always a concern that composite part has to be practically thrown out and replaced as it is, and even the replacement process is not as straightforward and simple as the metalworking is. So, any thoughts on repairability of composites, especially in the context of MT? Yeah, please.
If we are talking about the mass transportation repairability of the parts, I would say that it is very challenging, because all the time you have to inspect the part, because you cannot take it out every time, because the part is large size, and you cannot take it out every time. You have to repair on the spot or on the site. So that is the first challenge, that inspection. The inspection is must. No cracks, no any other damage or anything, warpage or anything. And all the time you have to inspect this, and then you need to. So for this repairing, you need the skilled person. So that is another challenge, that you all the time go on repairing, go on inspecting and go on repairing. That is a very challenging part, and that is what my views on the transportation repair, which are used in transportation.
That's a very interesting part of repairs. It's what at least I have come across. We typically see toilet modules in an ICF coach. I think people travel here day in day out by railways. So you see those FRP components in the toilet modules, which are 4 in number per bogie, right? So typically when the part is new, it looks very good. The train runs for 1 or 2 years. You start screwing metal strips on top of it, or having some metallic fragments on top of it. We have come across this situation many times. It starts looking really bad after, say, X number of years, after which the part has come under use. So that is where composites material can help us. Some trained professionals sitting at that repair facility or ICF or RCF, wherever the coaches are getting refurbished or repaired. So a skilled task force who has fabricated the bogie or the toilet module, a makeshift repair will only look shoddy, I would say. It will not look aesthetic. The aesthetic value is one. So that is one thing. Second thing is, during the transit, say I have prepared a metro interior coach, and it's getting transport from one location to site. So during transit, there are a lot of damages which take place. We have witnessed that many a times. So we have to station a next set of manpower at the facility, where there are experienced guys who do the repairs and do all the producing before the installation of the contents onto a rail coach or a bogie or metro interiors. So that is second aspect of the repair. So both have to be catered, where the crux is you have a skilled manpower sitting there, who's well known to the process, the curing pattern, the looks, the aesthetic, the colors. So those are the guys who will be able to create that difference, even for a used part or a new part.
See, this is typical example of how metal and composite are differing. Right. So if you talk about metal, come back to it in a minute, but if you talk about automotive, for example, we provide a lot of holes and so that some other part comes in and attach it. And the whole concept of repair is component based. So something goes wrong, then you take it out, you put it back again. That's how you go on. I'm talking about component, not just the surface that is damaged. Right. We're talking about surface because of about the superstructure. Right. But let's say if I use composite everywhere, then there is a different way we need to think. So if we think in a metal way, then provide all these fastener locations. And this material is typically bad for providing fasteners. Inherently, this material is bad. Eventually, these fastener holes will deteriorate and you will loosen out, and then it will have different implications on the component and it will get damaged. So I think what we need to do is the entire manufacturing has to undergo a change. So that has a big implication on the whole industry. Like now it is like supplying small components in supplying. But when we use composite, I think that approach may need to be changed or questioned. Like, can we have an integrated thing? Don't have to put together these things. It's challenging because making the whole thing integrated is again a difficult task. But there may be some way we can come up with attaching these parts in a different way rather than just with fasteners. It equally applies to aerospace industry or train industry. You use fasteners. So if there are tools there, like how we can go to kind of constructions.
Totally very interesting point you're bringing again, that we tend to extrapolate our thinking around manufacturing from the metal world, right? Which is why, especially in mass transport, what I've seen is that you create a FRP component, a carbon component, which is, let's say, 100 rupees, and the fastener which is applied on that may be like 300 rupees, right? So, in essence, we have locked ourselves in the thought process which is inherent with a metalworking domain. So, building on that, one question I have is around, in terms of getting some tips and directions for the industry participants. Majority of the Indian industry is built upon basic processes like and molding, and some degree of RDM and other infusion processes. Right? So, when it comes to the mass transport sector, the applications are technically where they're possible. Would you have any advice or pointers around what kind of capabilities the industry should focus on acquiring or refining, right? So that your composites can play a bigger role in the mass transport industry?
Like manufacturing point of view, always the process is better. Like the complete performance of the composite will depend upon the what method you are adopting to manufacture the composite, right? So, say for example, the majority of the components are like either being made from the dry fiber and then the other process that can be adopted like hand layup or vacuum infusion process. However, there is like enough literature available on the comparative analysis of the different manufacturing processes. As far as the mass transportation, like we talked about, so here the I can say the processability timing, that is also very much important, where like in a short period of time that maximum can be done. So conclusion is like obviously one of the method pre-make that now the people are also adopting the pre of the mass transportation components. So these are the few processes where this kind of can, so that is my submission on that.
Maybe picking up from what Sham just said, the monocoque design aspect, I mean, your tooling and then your mold making is the process where you could maximize the square meter of your area, which is part of your design. So if that design is intrinsic enough to ensure that your mold without having too much of attachments or so your mold is going to get to either your hand or your process or wherever. The larger the mold or the designer who sits over there can cover maximum square meters of area in that one mold. That is the time when you will be able to have least manufacturing time, because you are creating a module or that frame out of maximum 2 or 3 molds. So your tooling team and the designing team probably has to be equally responsive of creating a design which will result into a faster production time.
3D printing, that's the action. 3D printing.
I want to ask you all if there is a additive manufacturing concept which has gotten into composite domain. Any update on that? What's happening called composites? I'm personally not familiar, but I would imagine that some of you have heard of it at least. Or
As far as, I mean, today developments, we have now layup that we can, put together, and as some presentation showed in the houses. So the scale with which you can do is there. How much control you have on the property at the level, that is something we're not sure. Like if you want to use, let's say, for structural application, where you are subjecting the application to really loads like fatigue and all, what control you have. So if we talk about, let's say, talking 3D printing for houses, that is possible for the whole structure. Possible with all sorts of things arranged in one go, and that the entire setup is done with 3D printing. Then it will be fine. I mean, like you have less maintaining issue, carrying, and that with even if possible to mass produce. But when it comes to structural applications, I think 3D printing is not yet there. With, like what we design, what we can get out of 3D printing, I think we are not there. I think.
Even though like in that in not in India but in other countries that the 3D printing are also adapted to prepare the or to manufacture the tool. So basically, like what the time is taken, lead time is taken by the manufacturer that need metal. So the 3D printing can reduce the time for the tool manufacturer for the to make the component from the end lab process, not for the process, but yeah, that is for the end lab process. It can be is one way that where the people are working.
Certainly, the tooling using the 3D printing process to make tooling is definitely a good use case. I'm sorry,
I would suggest industry that they should give more time in designing and design of according to me some parts rather than larger, and because always the larger parts have the curing problems once you when you are making the parts while manufacturing, and these smaller parts can be as sir suggested should be attached in some unique way, and if in that way we are going to design the this problem would be, I think, would be rather solved. And the other thing which I agree with is that always we are trying to replace the part, and we are not making unique applicability of that particular composite. The design should be very unique, and it should not be for the replacement of the part, that you are replacing any wood or you replacing metal or something like that. It should be a unique application for that composite part, and it should be designed in that certain way. So perhaps the problem could be solved.
so we had a good round of inputs. And just attempt to summarize this a little bit. What I heard is that the good news is that there is a big potential for enhanced role of composites in the mass transportation sector, different applications. There are challenges in terms of its commercial attractiveness, in terms of safety, in terms of durability, in terms of design, in terms of fire retardants. But good news is that all those potential challenges, there exist solutions which have been tried, tested, and proven to be adequate. It's certain aspects may not be as widely present. So, for instance, durability, people are saying that you need to have skill craftsmen can actually repair, but there. So one set of conclusion is around the fact that there is a very bright potential and challenges which are there. There exist solutions. The other aspect which Professor Sham brought was to try and understand what's happening in the aerospace world. So there are lots of technologies and methods which have been developed, which in a way take a look at using composites as a material fundamentally different, trying to see a part-to-part replacement, especially in the context of assembly and manufacturing. What we discussed is that stop thinking of fasteners as the only way. In fact, fasteners is a bad way to put together composites. A more elegant solution to reimagine the manufacturing itself, perhaps along the lines of monocoque structures where you're replacing multiple small parts which are fastened together with larger, more complex monocoque type platforms, which obviously will require more complex designing and tooling, but that's very much here and available with facial and others available in the design industry. So I would say those two, I think, sets of insights came out very loud and clear. Any closing comments from any of you before we kind of wrap this up?
About the regulation framework. So that is one of the essential parameter for the qualification of the material. Still, like we are adopting the European standard that EN 4154, but still, like there is need to be developed the Indian standard where the industry should closely work with the this guys, like with them they can develop at least the Indian standard where the Indian, as per the Indian environment and the safety parameter can be designed. So this is one thing that where the master should allow.
Good point, yeah.
No, I really agree with Ankush. I mean, it's really something which is necessary, like building on standards. Very small nitty-gritties need to be brought under the scanner. I agree.
We've seen evolution of these standards coming into the Indian context as and how the penetration has increased. So when we talk about BIS, they are largely a subset or kind of evolved out of European standards and ASTM standards. So that was directly, the journey was linked with the amount of penetration and the application which is seen around us. So the same is with mass transport. We follow EN standards because that's what is valid today. The more metros come into cities, tier 1, tier 2, the application grows. That's where the approval agencies are coming into the picture. And that's when we start evolving towards our own standards. So it is a matter of time when it comes into context.
That use more composites will have more solutions with experience.
Any last words from you?
It's what she said. I mean, use more.
All right, so with that, we session and thank you very much for being a patient audience. Thank you. And
Any questions from audience? Okay. Yeah, please.
I don't have a big question. I have a quick comment on whatever what I heard. So mass transportation actually requires some mass production as well in line with that. That mass production actually requires mass customization because not every product is going in the same way. Just an example, if I consider aircraft as a mass transport, the seating arrangement, we are saying 250 seats in an aircraft, but most of the seats are very unique in dimension. Even 2 inch are different, 1 inch is different. You have to produce entirely a different set of product. So that mass customization is most essential thing. Otherwise, you will be never doing that kind of product anywhere because the tools will be different. For every inch, you have to have a different tools. That is another story. And materials and process is the key to entire thing. Design is of course, but we have to go into thermoplastics. For very quick production, mass customization, as well as for recycling. And India has to come up because we have so many polymer manufacturing. I mean, we ourselves, Reliance is doing a lot of stuff. Have to include glass and polymer or carbonate polymer, not necessarily P and T, but we can do PP and P. So that's just a comment.
so, thank you.
Yes, I mean, this is, sorry to add this. There's a very different philosophy when it comes to metro applications in India. Bangalore metro has to look different. Pune metro has to look different. Mumbai metro has to look different. It's like one part fitting into multiple metros is something what MMRDA or the manufacturers have to look at. But everybody wants their own designs to come. So that's where customization slightly takes a hit. So that's the only.
Thank you for the input. Okay, thanks. Just a moment, so please hold on. So with that, thanks for the fruitful discussion as well as the key inputs for all the audience. audience present here. Now may I request Professor Sunil Kale